Today we're going to have a look at an introduction to tolerance. So tolerance intervals or tolerance levels are margins of error that we allow for when we're taking measurements. That can be in different ways. It could be that the person, so the human that is taking the measurement, might not be able to get it 100% accurate. And it can also be that the instrument that you are using to make the measurements, whether that be a ruler or a scale for weighing things or a protractor to measure angles, isn't 100% accurate. So it just allows for a kind of range of values, and they are most commonly used in production and manufacturing or engineering. You might also have seen tolerance used in other subjects around the school. So in subjects like CDT, where you're being asked to measure pieces of metal or pieces of wood, or in science. The mathematical operations that you're going to be asked to do when you're doing tolerance questions are very straightforward. It's adding and subtracting or finding some basic percentages. That is not new to you, but what will be new is the new notation that we're going to be using, and we use a plus minus sign. Okay, and I'm going to show you some examples to show you how that would be used in practice. For our first lesson on tolerance, we're going to just look at quite simply stating the maximum and minimum values when given a tolerance interval. So the first example here says that the number of sweets in a bag is said to be 32 plus or minus 3. It says state the maximum and minimum number of sweets in a bag. So your first clue here should be the word state. And what that tells you is that you're just being asked to do something quite simple. And in this case, all you're being asked to do is add and subtract 3 from 32. So to lay this out, we're going to write max equals and min equals. Because we have 32 plus or minus 3, the maximum is going to be 32 plus 3, and the minimum is going to be 32 minus 3. We know that that's 35, and we know that this is 29. What this means is that if you were to open up a bag of sweets that said on the packet that there should be approximately 32 in the bag, there could be anything in there from 29 to 35 if that's what that company's tolerance level is. Anything below that, so if they packaged a bag of sweets and it was found to only have 27 in it, they would take it back and add more. If they packaged one and it had 40 in it, they would take some out. But anything in between 29 and 35 would be approved to be sold. For our second example, the numbers are slightly more difficult, but still quite simple. It says the volume of liquid in a can of juice is 330, and in brackets plus or minus 0.5 millilitres. State the maximum and minimum volume in a can of juice. So again, our key information here in this question is the 330 plus or minus 0.5. And what's slightly different about this question is that we now have a unit of measurement as well rather than just numbers. So we're still going to write max equals and min equals to represent our maximum and minimum values. For the maximum value, it will be 330 plus 0.5, and the minimum value will be 330 subtract 0.5. We know that this will be 330.5 millilitres. And for this one, we're essentially doing 330 take away a half. So it'll be 329.5 millilitres. So that means that even though it says on the can that it's 330 millilitres, if their tolerance level is plus or minus 0.5 mils, there could be anything between 329.5 millilitres and 330.5 millilitres. At Nat5 apps level, you'll most commonly be asked to find tolerance intervals including percentages. And that's what we're going to look at for the next two examples. So here it says a speedometer in a car has an accuracy of plus or minus 10%. If the speedometer reads 70 miles per hour, calculate the fastest and slowest speed the car could be travelling at. So in this example, we've replaced the words maximum and minimum with fastest and slowest speed. But when you're laying this out, you can still just write max and min if that's what you're used to doing. So max equals and min equals. Still following the same steps that we had been before. But we're not just adding and subtracting 10 onto 70, we're adding and subtracting 10% of 70. So over at the side, we're going to work out what 10% of 70 is. And we should all know that to find 10%, you're just dividing 70 by 10. So 70 divided by 10 equals 7. So when we're adding and subtracting, we're starting at 70, and for the maximum, or our fastest speed, you're adding 7, and for the minimum speed, you are taking away 7. So the maximum speed that the car could be travelling at is 77 miles per hour, and the minimum speed that the car could be travelling at is 63 miles per hour. Our fourth and final example says that the temperature gauge in a classroom reads 28 degrees Celsius plus or minus 5%. Calculate the highest and lowest temperature in the classroom. So highest and lowest temperature, again, just alternative words for maximum and minimum temperature. So max equals and min equals. We need to find 5% of 28. So we should remember from the percentages topic that there are loads of different ways to do this, and if the way that you prefer to do it is different to the way I'm going to show you, then that's fine. Just stick to the way that you're the most comfortable with. I would find 10% first, which we know is just 28 divided by 10, so 2.8. And if we know that 10% is 2.8, 5% will just be half of that, and half of 2.8 is 1.4. Remember, you're going to be doing this without a calculator, so you need to find a strategy that you'll be able to do without one. So the maximum, or our hottest temperature, will be 28 add 1.4, and our minimum temperature, 28 subtract 1.4. So the warmest temperature that it could be in the classroom is 29.4 degrees Celsius, always remember your units, and the minimum temperature would be 26.6 degrees Celsius.